Hey everyone, it's Miss Lloyd coming to you with some more triangle trigonometry, and we're going to be looking into the law of sines today. So with my students, I already went over the law of cosines. I've been doing a few more live Google Meet classes with them, and so I will be doing a few less of these as I get the chance to do more face-to-face, if you will, with my students. So law of sines, we have our formula here, and I know it looks like, oh, there's two equal signs, and this just means that you can set any of these ratios equal to each other. So I could have sine A of angle A over side A equal to sine of angle B over side B, and not have the sine of C, like that doesn't have to be there. I could not have the sine B and have sine of A over A equal to sine C over C. Any of those work out. And this works for any kind of triangle, meaning it doesn't have to be a right triangle. It can be an obtuse or an acute or something like that. And this we will typically use when we have two angles and a side, or two sides and an angle. So we'll use these for angle, side, angle, 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 side, and side, side, angle. Other times you could write it as angle, side, side, but that is not the nicest word to use, and I'm pretty sure my granny would be very disappointed if I did that. So we're going to say side, side, angle. And it's side, side, angle that we want to be careful with. I know many of my students, anytime I write this, they're like, oh, wait, but miss, we're not allowed to use this when we're doing side, side, angle. And that is because, so if you're given two sides and an angle of a triangle and the side opposite one of, or the angle opposite one of those sides, so in this case, side, side, angle, there might be two solutions, one solution, or possibly no solution. So anytime we are plugging things into our calculator and it gives us a nice answer, so i.e. we have either one or two solutions. If you have no solution, it'll come up as an error. But if we have a solution that it gives us, we do want to check to see if we have one or two solutions. The reason why we do that, so if we have a sine always stands for the y value of the angle that we have in standard form. And anytime we plug it into our calculator, so if we're trying to find the angle and we're doing sine to the negative first of something, that means we're trying to find the angle, and so our sine value, so let's say the point that I see here, that y value, x comma y, this y value here is actually going to be the exact same as the y value over here. I'll make that a different color. These are two different angles, but they have the same y value. This one will have a negative x, but it still has that positive y. Y, and in that case also sine, are positive in both the first and the second quadrant. So whenever we plug the sine negative first into our calculator, it's always going to give us the smallest angle. It's always going to give us the possibility that's just in the first quadrant. But we also have to worry about its double, or its equivalent, if you will say, what it would be the reference angle for in the second quadrant. So not only could we have an acute triangle with this orange that I have here, so I don't have to go straight down. This could be coming over this way, not sure. But we could also have an obtuse triangle going this way. So it depends on what we're given, and we do have to check on that just to be safe. So we could be making two triangles if we're only given one of these angles. In a triangle, so they've given us, now that I've kind of had that lengthy, kind of weird-ish, I feel like it was more word vomit than an explanation. So if you want a different explanation, please let me know. I'll try to organize my thoughts a little bit better than that. For our first example, though, we're looking at triangle PQ and R. And I've set it up a little bit. I just did a rough draft of it. It may not look like this. I'm just a visual person, and it makes more sense to me if I draw it out. And then that way I can also see what kind of triangle I have, if it's a sassy or an asymptote. My students would get that. Anyway, So they tell me side P is 3. So I have this over here. They tell me side Q is 4. I'm going to keep this the same color since they're associated with each other. And angle Q is 52 degrees. So I can use my sine, law of sines, because I have side Q and angle Q, and they want me to find angle P. So I'm finding this angle here, which is across from the side that they've given us. So essentially, I'm doing just one part of that formula. Again, you're not going to use all three, you're just going to use two of them, whatever two you've been given. So I can plug in what I know. We are in degrees, so you want to make sure your calculator is in degree mode. If you are in radians, this is not going to work out for you. And so for here, I'm trying to get sine of p by itself. So I'm going to multiply 3 to both sides. And then from here, I do want to get just the p by itself. I don't want to solve for sine of p. I just want to solve for p. So I'm going to be moving that sign to the other side. And in order to do that, I'm going to be using the inverse of the sign. So sine to the -1. So all of this I would plug in with my sine of -1. And when I end up plugging all of this in, you can plug it in all at once if you'd like. And when I do this, I end up with 36.2 degrees equal to my angle P. And so looking back at this, I have been given a side or angle side, if you will, or a side angle. This is one of the type of triangles you were told in geometry you couldn't do. So this is the one that we do have to be careful with. Pretty much any time you are doing the inverse of the sign, you do have to check your angles to see if it's something that you could have either one solution or two solutions. And so I'm going to go back up to here and kind of explain where that other angle comes from. We found 32 degrees so far. So the point, quote unquote, that this would pass through would have some x value, and then the sine of 32 degrees would be whatever the y value is. That's going to be the same thing. But not only is the sine of 32 this value here, but it would also match, again, the y value in the second quadrant. So I need to figure out what this angle is. And in order to do that, I know that since this kind of reflects over, this has a reference angle of 32 when we're coming up from 180 degrees. So to figure out what the other possible angle could be, so this darker blue angle, I'm going to be doing 180 minus my 32 degrees. Sorry, 36.2. Wow, I did that off quite a bit. It's another downside of not having my students here to correct me when I space out a bit. And when I do that subtraction, I would end up with 143.8 degrees. And so I have to ask myself if this makes sense. So if my largest angle, my obtuse angle, is 143.8, and the original angle that they gave me, angle Q, is 52 degrees from what they gave me. If I add this together, it's going to be over 180 degrees. So this angle here isn't actually a possibility for the triangle that they gave me that contains 52 degrees. So in this case, I only have the one solution for my angle P, and that's at 36.2 degrees. So this is a way to check. Pretty much anytime that you do the inverse of sine, the sine to the negative first, you do have to make sure that you don't have another possibility. So for our next example, they want us to find the indicated part of triangle ABC, the three significant digits, or to the nearest tenth of a degree. So if we're looking at sides, it's three significant digits. If we're looking at an angle, we're looking at the tenth of a degree. If there are two solutions, we have to give both. So again, if we're doing that sign to the negative first, we want to check ourselves before we wreck ourselves, figure out what the other possibility could be, and check that against what we've already been given. See if it could actually create a triangle or if it's too large. So then here for this first one, they've given me side A of 52. Again, this doesn't have to be exact or to scale. I typically don't put things to scale just because I don't necessarily need it to scale. I just like to have a visual so I can see what's across from what, and I can see if I have something that I don't know, maybe has some issues that I have to deal with. So if I have a side-side angle situation. So here they've given me side and angle A. They've given me angle C, and they want us to figure out what side C is. So I can set this up pretty nicely in my law of sines. So for here, I do want to try to get my C by itself. It's in the bottom, so that might be a little bit more complicated. So what I'm going to do is what I call the butterfly method, or cross multiplication. So I'd have 52 times sine of 38 degrees on one side, and that would be equal to C times sine 74 degrees on the other. So now in order to get the C by itself, I'm just going to divide my sine 74 degrees to both sides. And because I'm not trying to find an angle, I'm just trying to find a side, I don't have to worry about finding multiple solutions. You really only have to do that when you're trying to find another angle and you're only given side, side, angle. Here I'm given angle, angle, side. No, yeah, angle, angle, side. And so I don't really have to worry about it. And I can plug this whole left side into my calculator all at once. You can use some parentheses depending on your calculator. You might need them to figure out the length of side C. And when we plug this in, we end up with a 33 point, and it said 3 significant digits, so I'm going to say 3 whatever units. In this case, they didn't give us any, so this is what we got. And for the next one thing that I do like about these questions is that they don't make me solve for the whole triangle. And a little bit later, we're going to have to do that, and I can hear my students groaning already. All right, so I've moved the triangle a little bit because it does tell me that angle A is 18 degrees. So I'm going to say that's going to be a lot smaller than this, but I did want to maybe scale it just a tiny bit. And so side A is going to be 29. And it looks like side B is quite a bit larger, so I'm going to just put B here for funsies. And they want us to figure out what angle B is. So it looks like I have a side angle again. I'm going to be solving for an angle, so this is a situation where I have to be careful about what I'm doing, and I have to see if I get a solution. I've got to test and see if I have a second solution around the bend. So I'll have sine of my angle A, which was 18, over the side of A. And that'll be equal to sine, we don't know angle B, so I'm just going to put B there, over the side of B. And then I want to get sine B by itself, so I'll multiply 74 over. And I need to get B by itself, so I will be doing the inverse sign. Again, anytime you have to do the inverse of sine, so sine to the negative first, you do need to, sorry about that, you do need to make sure that you're checking for multiple solutions. So plugging this into my calculator with a sign of negative first and all, I would end up with B being equal to 52 degrees. Now, the last time that we had to double check both, we had a pretty small angle of 36.2 after I corrected myself. Having a larger angle like 52 means that we have a greater possibility of having a second angle. So 52, I'm going to rough it. It's going to be about here, 52 degrees. So if I draw its reflection on the other side, this is the other possible angle that we could have for that same sine. And so since I have a reference of 52, that means I'm doing 180 minus the 52 degrees, which would end up giving me 128 degrees. So if I were to add this to the angle that I already had, so they told me 18 degrees, I would still have plenty enough room for a third angle. We know that all three angles in a triangle have to add up to 180 degrees. So 128 plus 18 gives me enough room to have another angle. Even if that angle is 1 degree, it's still something that you have to take into account. So 52 degrees or slash and 128 degrees. So it's going to be both of these. Here are both of our possibilities. Another situation, this one's a better situation because we're trying to find a side. Yes. And my phone keeps going off. I apologize. I'm just really popular and I can't help it. Sorry. Alright, so I've got A, B, and C. They've told me that side C is 73. And they tell me that angle A is 27 degrees. And angle B is 34 degrees. And they want us to figure out what side A is. Now, in order to use a law of sines, if I want to figure out what A is, I need to have sine of A. So I have sine A is a 27 degrees over, it'll help me figure out what side A is. And I need to set this equal to something that I have both the sine and the opposite side of, or the angle and the opposite side of. So they've given me angle B and side C. So I either need to figure out what angle C is or I need to figure out what side B is because I need the opposite side of whatever angle I'm using. And because I already have two angles from the triangle, it's easy enough for me to just figure out what the third is by subtracting from 180. So whenever I do the whole 27 plus 34 and subtract that from 180, I end up with 119 degrees, which is a lot larger than the angle that I've actually drawn. So again, keep in mind, I do not draw this to scale. It's just to help me kind of visualize what's going on. So now I have sine of my angle over its opposite side. So that is one of our rules of sine. It's always the angle, the sine of the angle over the side opposite that same angle. So we want to make sure we have both of those. Now that I have that, I can do a little finagling in order to get my side A. This would be a great time to pause the video and figure it out yourself, and then unpause to figure out how I did it and to check your work with mine. All right, and so I end up, whenever I plug in all this stuff here on the left into my calculator using parentheses if you need to, I end up with my side A being 37.9. And again, it did say that I need to give to 3 significant digits, so this explains my rounding process. And then this is my last one. So the last question that I'll go over with you guys, and I wrote pickup line for a reason. Give me a second here. So they want us to find the exact value of A over B. And so notice that they give us a small a and a small b. So this means that they're wanting us to find side A and side B of our triangle. So if I were to draw it out, they're wanting us to find those two sides. So, and there's also the nice key term exact. And so they tell us if sine of A is 1/2 and cosine of B is 3/4. So if I were to do this, if I were to figure out the sides, that means what I know what sine of A is. If I could figure out what sine of B is instead of cosine of B, then I could have the whole sine of A over A equal to sine of B over B. I can start using this process to figure out what this might be. If I were to do my dividing or my cross multiplication, I would have B times sine of A equal to A times sine of B. I can divide my sine of B over, divide my B over in order to get that A over B. So I would end up having sine of A over sine of B equal to A over B. So once I figure out what sine of B is, I can plug all of this stuff in, do a little simplifying, and figure out what exactly A over B is. But in order to do that, I need to figure out cosine of B, or I need to figure out sine of B, but they've only given me cosine of B. So this is where my pickup line comes from. My students already know this because I gave it to them in the last notes that we did. The pickup line that I like to use is, hey, if you were sine squared and I was cosine squared, together we could be 1. So you see someone you think is cute, say, hey, how about you be sine squared and I'll be cosine squared, and together we can be 1. It's super romantic, it's super nerdy, and if they don't get it, maybe they aren't smart enough for your massive nerdy intellect. Or they just think you're really weird. It could be either one of those, we're not going to judge. So if I know the cosine of something, I can actually use that to figure out the sine of it. So since they've given me cosine of B is 3/4, I can plug this into this little formula. So sine squared of B plus, we know cosine of B is 3/4, and squaring that is just, anytime we have cosine of B squared, is just squaring the actual value. So then sine squared of B equals 9/16, and I would subtract that to the other side. And 1 is technically 16/16, so I'm doing 16 minus 9, which would give me 7/16. And in order to get rid of that square, I will have to take the square root. And since I don't know the square root of 7, I'll keep it square root of 7. And of course, the square root of 16 is 4, so I can do that. And now that I have my sine of B, which is square root 7/4, and I have my sine of A, which is 1/2, I can plug that into the equation that I made to figure out what A over B is. So now I have 1/2 over, this is really disgusting, square root 7/4. This is equal to A over B. I don't feel like this is something that would be readily acceptable, so I'm going to start simplifying. Because I have a fraction over a fraction, I can do same change flip, or keep change flip, or however you would like to say it. So I end up with 4/2 times square root 7 equals my A over B, and it's not really rational to have a square root on the bottom, so I'm going to rationalize my denominator. Oh, I can also simplify that a bit and end up with square root 7 to square root 7/7 as my A over B. They don't ask for the individual A or B, they just want the whole form of A over B. So this is kind of my shortcut of doing it. That's all that I have for you today. If you're one of my students, you can check out your homework on the LMS. I am going to be flying back home, so hopefully we will have a lot more live Google meetings. I'll be able to do that once I'm in the appropriate time zone. Unfortunately, that means that my viewers who are not my students, you're going to be seeing a little bit less of me, And that doesn't mean that I'm not here for you. So please like, share, subscribe, and comment if you have any questions. I will totally make a video. I'm here for all. Share the love.